Hey everybody, we're going to start getting into series circuits, and there's going to be a separate one for parallel and then your series parallel circuits as we go along. Anyways, let's go ahead and get started. So series circuits, I think, are probably the simplest one to understand, but sometimes it gets a little confusing to some people. So please go ahead and contact me if there's any extra help you need with this, and we'll go from there. So I'm going to start with a very basic on series circuits, and then we'll go on. So series circuits, we really need to understand the different laws that apply to them. There is Ohm's Law, which you probably heard a lot about. We actually talked a little bit about Ohm's Law in one of the previous videos I put up. But there's also another law that we need to think about too. Of course, there's Watt's Law too, but there's also Kirchhoff's Law. So we're going to talk about that too as we go along. So the Ohm's Law, we kind of discussed a little bit, but to me, it seems to be a little bit easier to understand. Kirchhoff's law can be easier to understand too, but we'll get into that as we go along. So a definition of a series circuit is a complete circuit that's only one path. So we have this particular series circuit right here, and we have a positive, part of the battery. And then we go into one bulb here. We can actually have it really super simple. We just take the one bulb and go through, but we have actually three bulbs here. So what we're trying to demonstrate here is that we have different circuits that have different loads, or I consider bulbs loads, or something that's going to do work for you. So this is what we're trying to get down to, and we're going to be getting into class talking and getting deeper into these laws, Ohm's Law, like that. So they have one path going through, and Ohm's Law and series circuits. A series circuit is a circuit containing more than one resistance in which the actual all current must flow through all the time. Ohm's Law can be used to calculate the value of one unknown, whether it be voltage, resistance, and amperage. So you have your voltage supply here, and then you have your loads across here. So now, because we already know what our resistance is and what our battery is, we can actually calculate how much amperage is going through this circuit. And we can do that with a simple circuit. And if you think about it, if we just had 1 ohm of resistance and that was the only bulb in the circuit, we would have 12 volts here, and we would have 10 amperes of circuit going through. You kind of get it like that. And we can figure the whole amount going through here by adding the resistance together. And we'll get into that in just a minute here. I've got a few little demonstrations here for you. So this is what we've seen just a minute ago. So if I have 12 volts and then I have a circuit, so I've got a resistance here and a resistance here, and I have these bulbs going through. Okay, so now I have 3 ohms of resistance. So with 3 ohms, then we'll actually have, I'll give you a few seconds to figure that out. Simple dividing, folks. I'm just kidding. Anyways, so if I have 12 and I have 3, then it's going to give me 4 amps of actual current flow going through there. So you just take this number, and if you want to go back to the early Ohm's chart, remember the Ohm's Law chart, that little pi or that triangle, whichever one you do, you actually divide the actual resistance into the actual voltage, and that gives you the actual amount of current flow. And you can do that in even more complex circuits. You know, you add more bulbs into it. You just got to figure out your resistance, figure what your battery is, and then you can figure out the amperage. And you can go the other way around. You can actually go, I don't know what the the resistance is, the total resistance. So then you need to start looking at what the amperage is and the voltage is. It's a little more complicated when you're trying to figure out the regular those bulbs, but we can actually get to that too. All right, so another good guy here, Kirchhoff. This is I call it Kirchhoff, but I guess it's called Kirchhoff law. The voltage that applies through the series circuit drops with each resistor, and this is important when we get into voltage drop a little bit deeper. I want you to understand that, because this is one thing especially in our field, where I don't feel technicians do voltage drop as much as they should. Now, we can calculate until the day is in using Ohm's law to figure out what the resistance should be, or what the amperage should be, or what the voltage should be by our formulas. But when you turn things on, everything changes. Your resistance changes, because anytime you get a load and you start putting current through it, you're going to end up heating it up. So knowing that with heat, the resistance increases, so that kind of changes everything. So it's really important that you know that, and stay tuned for the voltage drop part. I think that's going to be really, really beneficial to you. So continuing on, I tend to get sidetracked here, but if we look at Kirchhoff's law, the current through the circuit is determined by using Ohm's law. So we can actually figure out using Ohm's law, so we can actually look at it. And then if we take like this particular circuit here, I have 12 ohms of resistance. Okay, we have one bulb one is 2, 4, and then we add another one. So we have 12 ohms of resistance. We know it's a 12-volt battery, so then we have 1 amp of actual flow. But everything is known except for the voltage drop. So this is where we start looking at how much voltage drops across here, how much voltage drops across here, and how much voltage drops across here. So what we can do is use Kirchhoff's law, and we're going to actually go ahead and do some actual voltage drops prediction across it. So we need to actually have some a kind of a formula for that. So we'll start off with start off by looking at our resistance. So we know we have 6 ohms of resistance. So if I divide that across the first circuit, I have 4 volts dropping across here, and then I go across and I gotta drop the rest of it. So if I take 4 plus 8 equals 12, I've got it made in the shade. But the voltage that I need to actually go across is actually by going across the actual resistance across to it. I hope I didn't lose you there. All right. So if you look at it, my resistance is 6 ohms and of total resistance. Okay. And then if I take my first and I go across, because remember I had 2 amps going across it. So if I take that and multiply that by 2, so my 2 ohms by 2, then I know I have 4 volts drop. If I multiply again by 2, I'm going to have 8 volts to drop. So you add them together and you should have 12. So the biggest thing is confirming, especially when your load's on. This is where I really encourage you in lab to experiment. We're going to use the circuit boards to actually experiment a little bit, and then you're going to be able to see actual voltage drop. And this actually shows a voltage drop here of just light bulb over here. So we have the voltage drop across this load. We need to know what the load is to figure out what our voltage drop is going to be across. But by the end, we should have complete voltage drop. So we should be on the negative side of this circuit. We should be that full voltage drop, and we shouldn't see anything at all. So we should be close to zero. We'll talk more about the parameters on voltage drop when we get into the voltage drop section of our series going on here too. So again, we'll have a good voltage going in, or at least we should. If we don't, then we're going to actually have a problem with that wire going across. And if we don't have a full voltage drop on the back side here, then we need to figure out where our problem is, where our resistance in this wire or this connection might be. And then this is showing a completed circuit by wire. When we get into frame diagnostics and stuff like that, where we use the frame to actually be the ground, then we can actually have a problem on that side of it too. All right, so series circuit laws, there's a few different ones. The law one, the total resistance in a series circuit is the sum total of the individual resistances. The resistance value of each electrical load are simply added together. So that's what we've done already. And the current in this is the same throughout the whole circuit. So it has to be the same all the way through. Then, we don't have a change in resistance. It kind of stays the same. That's how we get our actual total drop going on. And then, if of course, like I give you a couple different examples here. So if I have a resistor 1 and a resistor 2, I don't know what this resistor is, but I know what the amperage is. Okay. So if I know what the amperage is going across that circuit, let's figure out this actual resistance. So my amperage is 3 amps of resistance. So I know I've actually dropped across this one. Okay, so I actually go ahead and add that up. So I got 6 ohms of resistance, and I know I have to continue to drop the rest of this. So 6 ohms. So if I have 6 ohms, I've got to have 1 ohm over here. So my resistor 2 has to be 1, because that would be 6 and 6 equals 12. And then when I go into other calculations, you can see the other calculations that I put up here. This is kind of my example number 3 for you. And, if I take the total resistance total, that's what the RT stands for, equals 1 ohm plus 1 ohm plus 1 ohm, it equals a total of 3 ohms. And then if I take my voltage, I don't know what my voltage is, but I know what my total amperage is, because I'm showing it here. My amperage is flowing. Okay, so all I have to do is take that amperage and multiply by the resistance, and I get my total voltage. So it's kind of this is maybe a little bit confusing, and I would actually play this over so you can go back and look at it again. Always remember to do your reading also. So just in summary, in a simple circuit, the current remains constant through the whole voltage drops as the current flows through each of the resistance of the circuit. The voltage drop across each resistance or load is directly proportional to the actual value of the resistance compared to the total resistance in the circuit. The sum of the voltage drops equals the applied voltage. That's under Kirchhoff's law. And an open or a break anywhere in the circuit stops any kind of current flow. And And keep that in mind when we get into the parallel circuits. All right, folks, I hope this was beneficial. It was. Please make sure to leave a comment down below if I missed anything. Also, if this was beneficial, make sure you like this video and subscribe for more content coming through. All right, take care now. Bye, friends.